This is an eBay package. Standard priority mailbox. I like people that use padding from the post office. Our tax dollars at work. And you can see what it is. It's a WR-50C generator. Brand name VIZ. A couple of videos ago I did a series on a WR-50B, which was a tube type RCA oscillator, just like this. This is the C version, so it's a solid state version. It's a little bit dirty, and he uses the audio connectors for modulation in and out and RF out. I'll probably change at least one of these, maybe both of them, to BNCs. And it's pretty dirty, so I think I'll give it a superficial cleaning up. These things normally go for about $1.50 on eBay. I bought this one for $99 plus $13 shipping, so a little more than $100. And the description is like this. This fella had 3 of them. I bought one, so it's down to 2. And this is his name, the seller. It's cleaned up pretty nice. There's a lot of streaks on it because I just used, what did I use? Formula 409. Couldn't find any Windex. If you take this knob off, be aware it's an 050 Allen single screw. Oh, there it is. So I'm going to take, well, we'll look at it once. As I said before, I like to replace these with BNC connectors. I have a warning at the top. Two holes down here. I'm not sure what they're for. I'm thinking that it's got a permanently connected line cord. This is probably an access plate to calibrate the coils. And it'll probably have to come off in order to get the line cord, because that's not going to fit through the hole. It does have an aluminum sticker here. It's dated 11/81. I remember when this happened. I'm not sure why it happened. RCA spun off its test equipment to an organization called VIZ, and that may have also been RCA's training outfit. This will have to be taken out in order to pull the chassis out. So we'll get ahead on that. Again, these are self-tapping screws, not machine screws. And you can see these are the coil, well, these are the capacitors, and down in here you have to use a hex tool, plastic hex tool, to adjust the inductors. I believe there's 4 of these. Again, they're self-tapping screws. Transistors are socketed, that's interesting. An integrated circuit that's not socketed. This is a line coming in. If you don't want to screw with that, that's a good place to stay away. Now, once it goes through the bottom of this chassis, 110 volts disappears here. So everything on this chassis is low voltage. And with the exception of this area here, and the power switch, which is these 2 wires here, everything else is low voltage. So I have the 110 volts coming in, or 220, to this terminal strip. The hot leg comes up here where it's switched, and then it disappears into the transformer. So there's where you could get shocked, or here. Everything else is low voltage. The indicator is an LED, so that's 3 volts. Let's at least see if it works. Oh, VFO was turned off, and now I got lots of output. Still not right. Alright, dude, we just have a dirty potentiometer. Very dirty potentiometer. I'm reading right now 528 kilohertz, and I'm on C, which is right. There's 550. Well, it's exactly 550 on the oscilloscope. Let's try other ranges. Okay, B and C work. Reading now, let's see, I'm on the A scale, which is here, and I'm reading 87 kilohertz, which is probably right. Here's 85, let me see, reads 86, looks like 85, turn it up to 100. And it reads 100. Go the whole way up to F, which is a high end of the scale. Go really high to 40 megahertz. The output fell a whole bunch, but I think that's part of the problem with this potentiometer. The E scale, which would be here, and we're looking at 13.5 megahertz. And I have 13.5 megahertz. Doesn't, every once in a while something is happening. I'm going to clean these controls a little bit. And I'm going to go ahead and remove these audio jacks and put in B and C jacks. Then I can hook it up to the scope and we can see what's going on. So I've taken these wires off. I didn't take the ground off yet. Interesting to note, this phono connector has a ground lug. It's the RF output. But this one, which is an audio input-output, does not have a ground lug. It just uses the chassis. There we go. Now you might say, why am I taking audio connector out? Well, looking around, my equipment all has BNC connectors, even my audio oscillator. So I think BNC connectors are more appropriate, certainly for the RF output over here. In order to enlarge these holes, which we'll have to do for the BNC fittings, I'm going to use this tapered hand reamer. I'm not going to take it to a drill press and try to dick around with positioning it and reaming out the holes with an electric drill. This one was made in India, and you can buy these for about $5 or $7. Called a hand reamer. I've used this one for years. It's not dull. I've abused it. Now you should never turn a reamer backwards, although we're cutting aluminum here. I don't know why I'm cutting it from the back. I wouldn't have any obstacles if I was cutting it from the front. And don't over-ream it. I may have really shot myself in the foot. I got this wire caught in the reamer, tugged on this control, and now the potentiometer's loose. I already thought maybe I had a problem with that potentiometer. Now I may have to replace it. But the BNC connectors fit fine. So I'll solder them all up. So the audio connectors have been replaced with BNCs. See how they look from the front. Not bad. All the lettering fits the BNC connector. I've left this run overnight. Yesterday, before I quit working on it, I sprayed the internals of all the switches, the bandpass switch and the two potentiometers. And looking at the waveforms, it looks like everything works. Tunes very well. So in part two, we'll take a look at the output signals. I'm going to put this back in the case. I don't like having this 110 volts exposed. I was able to find a manual online. In fact, I was able to find a number of manuals, but they all appear to be copies of the same poorly done PDF. But beggars can't be choosers. This information, as well as the information on the B model, is all in one subdirectory. So when you look at it, make sure you distinguish between the C model and the B model. And that subdirectory is linked below. Virtually identical specifications with the B model, except that this is equipped with a 600 hertz modulating signal as well as audio output signal. So the other one was a 400 hertz. Everything else is about the same. The C manual contains no theory of operation. It does, however, contain a lot of troubleshooting, that is, troubleshooting other equipment using this sweep or the signal generator. And the only differences between the C and the B model, which contain the same troubleshooting information, is that the B model was working on vacuum tube consumer electronics, while the C model is working on transistorized equipment. The online manual includes a schematic. Actually, it includes two schematics. One of them is marked void and is replaced with the one I printed. I can't tell what the difference is without looking at in detail, and there doesn't appear to be a serial number where the old schematic is replaced by the new schematic. If you watch my videos on the B model, this is virtually the same. Hartley oscillator, selector switch, and this is the active component of the Hartley oscillator. So the Hartley oscillator is followed by an amplifier, which receives, depending on where the switch is, the modulation switch is positioned, receives modulation through this capacitor, which is coupled down here across the resistor. This is the output of the RF portion, and this signal here coming through this capacitor. Effectively, AM modulates this, depending on, as I say, the position of the switch. In part 2, we'll take a look at the signals, the accuracy as received. I'm not going to calibrate it just yet, and we'll see what the controls do. So, if you're interested in the WR-50C model, come back for part 2. Thank you.